Find the square root using long division method. Now here we can see that we have studied how to find the square root using prime factorization method, but for bigger numbers it will not be that much easy to do prime factorization. In that case you can use long division method. Now we will consider an example. We have here 20,164. We are going to find the square root of 20,164 using long division method. Now for finding the square root using long division method, first we have to group the digit in pairs starting with the digit in the units place. I mean here this is a given number 20,164. From the right side you have to start and make the digit in pairs. So here we can take two digits, they will form a pair, then again next two digits they form another pair, and the third one 2 is left alone, so 2 is one pair, one group. So now after grouping the digit in pairs we have to start the long division. And one more thing, each group we will call it as period. So here 64 is a period, 01 is a period, and 2 is a period. Now we will start with the long division. When you start the long division you have to first consider the first period. Here first period is 2. Now think of the largest square which is equal or just less than this first period 2. Think of the largest possible perfect square which is equal or just less than this first period 2, and we know that it is 1. Perfect square possible in 2 is 1. So 1 multiplied by 1 we can write 1. After that find the difference, subtract difference of 2 and 1. 2 minus 1 is 1. Then same like in division, we have to take down the next period, next group as such we have to write down. So next period is 01, so write 01, then it will become 101. Now next step, our first quotient was 1, we have to double it. So double of 1 means 1 multiplied by 2, answer is 2. Okay, now we have to find the new divisor. This is the new divisor. Find the new divisor by finding a suitable digit which comes here. At the same time the same digit will appear on the top, so as to find a suitable number possible in 101. So when you write after doubling the quotient it will become 2, then you can start with taking suitable number, like for example 1, then it will become 21. Then we should write 1 also here. 21 multiplied by 1 is 21. 21 is possible in 101. Same like that, continue with suitable digits and find out the largest possible multiple, and find out, we can see that 24 multiplied by 4 will become 96. Then find the difference, 101 minus 96 will get 5. Then same as we did early, take down the next period, next group as such, then we will get 564. Then next step, take the quotient. Now the quotient is 14. 14, after doubling 14 will become 28. Then find a suitable number to find the largest possible multiple. Then if you start writing, we can see that 282 multiplied by 2 is 564, and the remainder will be 0. Then we can say that square root of 20,164 is exactly 142. Now consider another example. We have square root, we have to find the square root of 64,516, and here same First step, what we have to do is from the right side we have to form group of 2 digits. So from the right side, group the digit in pairs, starting with the digit in the units place. Then take the first period. Here first period is 6, and find out the largest possible perfect square in 6. It is 4, and 4 is the square of 2. So 2 multiplied by 2, we will get answer 4. Then remainder 6 minus 4 is equal to 2. Then take down the next pair 45, we will get 245. Then next step, we have to find the suitable divisor for that. Right now we have only one number in the quotient part, that is 2. Make it double. Double means multiply by 2. So 2 into 2 we will get 4. So write 4. Then find a suitable number which comes here, so that this whole number multiplied by this number comes a possible number out of 245. We can see that 45 multiplied by 5 is 225. So we can write 5 here, then 45 multiplied by 5, we will get 225. Then finding the difference, remainder will be 245 minus 225, it will be 20. Then take down the next period, that is 16 as such, then it will become 2016. Then now the quotient part is 25. Double it. 25 multiplied by 2 is 50. Now the third digit, the number in the divisor, suitable divisor. To find the suitable divisor, find a suitable number that satisfies. So we can see that 504 multiplied by 4 is 2016, and the remainder comes 0. So we can say that the square root of 64,516 is 254. Now we can consider another small example, square root of 1369. Square root of 1369. Now when we start the long division, from the units place, from the right side, you have to make digits in pairs. Then each pair we will call it as period. So here 13 is the first period, and find out a suitable largest perfect square possible in 13. It is 9, and 9 is the square of 3. So we can write 3 here, and the quotient part also we can write 3. 3 multiplied by 3 we will get 9. Then finding the remainder, 13 minus 9, we will get 4. Then take down the next period, that is 69. So then the new dividend will be 469. And now to find the divisor, the first digit will be double of this 3. So 3 multiplied by 2, we can write here 6. Then the next digit, to find the next digit, find a suitable number. By putting 1, 2, 3, we can find the suitable number which comes here. Then we can see that 67 multiplied by 7 is 469. So we can write 7. Then the remainder is 0. Therefore we can say that the square root of 1369 is exactly 37. So this is the way we have to do long division. So while performing long division method, whenever you get a number, first step, group the digit in pairs, starting with the digit in the units place. Each pair and the remaining digit, if any, we will call it as a period. In the first example, we can see that this is a second example. We can see that here after making digits in pairs, 6 is left. So this is also considered as a period. Then second step, think of the largest number whose square is equal to or just less than the first period. Take this number as the divisor and also as the quotient. So that means here in this example we can see that we will take the divisor like this. First number will be the double of the first quotient. Then we have to find a suitable number here that will be the same as the number here. Then step 3, subtract the product of the divisor and quotient from the first period and bring down the next period. So after subtraction we have to take down the next period to the right of the remainder. Here remainder is 2 and next period is 45. So 45 should be written to the right of the next period. This becomes the new dividend. So 245 will become the new dividend, and then we have to continue the long division same like as we did earlier. So next divisor, so new dividend will be 245, and to find the divisor we have to take a double of this quotient 4, then we have to continue. Then step 4, after finding the new divisor we have to take the digit chosen in such a way that the product of new divisor and this digit is equal to or just less than the new dividend. So here then after taking the next period to 45, then the new dividend will become 245, and then to find the divisor what we have to do is first we have to double the quotient, then 2 multiplied by 2 will become 4. Then to find the next digit what we have to do is this digit 5 is chosen in such a way that the product of the new divisor and this digit, that's why we are writing here 5. So the new divisor and this digit means the number written here, which is same as this number. The product of these two numbers must be equal or less than the new dividend. So here we have to find out a number which is either equal or just less than 245. Such a way we have to select the second number, and then we can repeat the steps again by taking the remainder, then take down the next period, and we can continue till we get 0 as the dividend. Then we can find the square root.